look at how to write an explicit formula for the nth term of a geometric sequence. So if we want to write an explicit formula for the nth term, we have this formula for doing so. A sub n, which stands for the nth term of the sequence, is equal to a sub 1, whatever the first term of the sequence is, times r, which is the common ratio, to the n minus 1 power, where n is the term number. So I could, as long as I knew the first term, as I could tell the common ratio, I could find any term number I wanted of the sequence. If I knew I wanted to find the 50th term number of the sequence, assuming that I knew the first term and the common ratio, I could just plug 50 in for n, and then I could go ahead and compute. So let's take a look at this example that wants us to write an explicit formula for this geometric sequence. So to be able to do that, remember a sub n is equal to a sub 1 times r to the n minus 1 power. That will be our formula for writing our explicit formula. We need a sub 1. We need the first term, which we have. So a sub n is equal to 4 times r, the common ratio, which I can look, the common ratio here is 3. I'm multiplying by 3 to go from one term to the next. I can see that by putting 12 over 4, that's 3. 36 over 12, that's 3. I can see that common ratio being represented. So I have 4 times 3 to the n minus 1 power. And that is my explicit formula for the nth term of this sequence. Please don't try to go ahead and multiply the 4 and 3 together. You would be violating the order of operations if you did that. You can't do this multiplication before you've dealt with this exponent. So that actually does not simplify any further than that. That is my explicit formula for the nth term of the sequence. Now, the question also asks me to find the 7th term of the sequence. So I'm just going to go ahead and plug that in. So a sub 7 will equal 4 times 3 to the 7 minus 1 power. So that's 4 times 3 to the 6th. So then I go ahead and I compute that. 3 to the 6th power is 729. So I have 4 times 729. And I should get that a sub 7, the 7th term of the sequence, is 2,916. So I wrote an explicit formula, and then I used my explicit formula to find a given term of the sequence.